In this video, I'm going to look at designing a database for Woof Grooming. I'm going to use the entity relationship diagram method. Let's just have a look at our database. We've got some information straight away. We've been asked to create a database for Woof Grooming, a dog grooming salon. The database will record information about customers, dogs, treatments and appointments. Each treatment has a different cost depending on the skill and resource required. There are currently 5 types of treatment offered: cut, wash and brush, nail clip, teeth cleaning and cut, wash and brush. And we're told that the cost per treatment must be between £20 and £60. We've been given some data to go with that information as well, and it's a good idea in your own words to describe what the database will be about and to identify any primary keys. That's something that will uniquely identify an instance of an entity, and also to try and describe the relationships about the data as well. So let's just have a look at what we've got here. We've got attributes, dog ID, appointment ID, treatment ID, customer ID, dog name, dog breed, customer surname, telephone number, appointment date, appointment time, dog groomer, treatment name, duration and cost. So let's just have a look at the data, see what we can surmise from it. So we've got a dog ID 1, 2, 3, 4, 5, 6. So dog ID 1, that's Willie, pug, owned by Spence. Dog ID 1, Willie, pug. So the dog ID identifies the dog name and the dog breed because the name and the dog breed are the same for the dog ID. Then we've got an appointment ID, and it's 1, 2, 3, 4, 5, 6, 7, 8. And if we look at this appointment ID and come along, the appointment has got a date. So appointment 1, 1st of December 2020, appointment 2, 1st of February 21, appointment 3, 28/11. So each appointment ID identifies a different appointment date, and then for each appointment we've got a time, and we've also got a dog groomer allocated. Now let's have a look. Treatment ID. Treatment 1 is wash and brush. Have we got any other treatment ones? No. Treatment 2 is nail clip. Have we got any other 2s? Yeah. 2 nail clip, 2 nail clip. So the treatment ID identifies the treatment name. So for each treatment ID, we've got a different treatment name. And then let's just have a look at the duration and the cost. So let's have a look at nail clip. That's 30. Have we got any other nail clips? Yeah, that's 30. And then if we look at the cost as well, nail clip is 20, nail clip is 20. That cut, wash and brush, that's 120 and 60/50. So the treatment ID identifies the name, the duration and the cost. Let's have a look at the customer. We've got a customer ID 10, that's Spence, and we've got a telephone number 10 Spence, same telephone number. Then we've got 40 Cassidy, same telephone number, 40 Cassidy and the same telephone number. So that customer ID tells us which customer it is and what the telephone number is for that customer. Now, if we just have a look and think about relationships, so let's start off. Can a customer own more than one dog? And if we look at customer 50. Customer 50 owns Petra and Bullet. So that tells us a customer can own more than one dog. Let's look at that the other way around. Can a dog be owned by more than one customer? And the answer is no. Each dog is owned by one customer. Okay, let's have a look at, can a dog have more than one appointment? And the answer to that is yes. If we look at dog number 1, Willie, he's got 2 appointments. So a dog can have more than one appointment. Or can there be a number of dogs at one appointment? And the answer to that is no. There's only one dog at an appointment. Now let's have a look at these treatments. Can a treatment be given at more than one appointment? And the answer to that is yes, because if we look at treatment number 5, cut, wash and brush, that's being given to 2 separate appointments, appointment 3 and 4. And if we look at that nail clip, for example, number 2, nail clip, that's being given to 3 separate appointments. So a treatment can be given at many appointments, but an appointment only has one treatment. In our own words, this database is going to store data about dogs, appointments, treatments and customers. In terms of our primary keys, things that tend to have an ID after them tend to be primary keys. So I think we've got dog ID, appointment ID, treatment ID and customer ID are going to be the primary keys. And then in terms of relationships, a customer can own many dogs, a dog can have many appointments, and a treatment can be applied at many appointments. So just to summarise that, this database will store data about customers, dogs, appointments and treatments. The primary keys might be dog ID, appointment ID, treatment ID and customer ID. And the relationships might be a customer can have many dogs, but a dog has one owner. A dog can have many appointments, but an appointment is for one dog. And a treatment can be given at many appointments, but an appointment only delivers one treatment. The first thing to do now is to draw up an initial ID from the information that we've got so far. So here we have an initial ERD. We said we had a customer, can own many dogs. A dog can attend many appointments, and a treatment can be given at many appointments. The next thing is to add the primary keys. So the primary key for customer is customer ID. The primary key for dog is dog ID. The primary key for treatment is treatment ID. And the primary key for appointment is appointment ID. We then just have to check our ERD to make sure there aren't any many-to-many relationships. So are there any issues to be resolved? So in this database, there are no many-to-many relationships between any of the entities. All the relationships are one-to-many. Therefore, there's no need to create a new entity to deal with any many-to-many relationship. The next stage in our design is to add the foreign keys. On the many side of a relationship, you need a copy of the primary key from the one side of the relationship. So if we look at dog and treatment, right, they've got a many side. The asterisk is used to signify a foreign key, and foreign keys are needed to be able to form the relationships between the tables when it's implemented in Access. So let's just have a look at this in a bit more detail. If we look at this many relationship here on the dog side, what we're saying is we need to go to the one side of the relationship, that's customer, pick up the primary key, customer ID, and put that in our dog entity as a foreign key. So there we see customer ID with the asterisk after, which signifies a foreign key. Let's now have a look at the one-to-many relationship between treatment and appointment. So we go to the one side, treatment, pick up the primary key, treatment ID, and we put that in appointment as a foreign key. So there's treatment ID with the asterisk. And then finally, we've got a one-to-many relationship between dog and appointment. So on the many side, we go to the one side, pick up the primary key, which is dog ID, and we put that in appointment as a foreign key, and there's dog ID with the asterisk behind it. The next stage in our design is to add the attributes to our ERD. And what we're going to do is take each attribute and decide which entity they best belong to. We need to ask ourselves this question for each attribute. Is the attribute totally dependent on the primary key of the entity, i.e. is dog name dependent on dog ID? And the answer is yes, because every time we have a change of dog ID, we have a change of dog name. Another example is the appointment date dependent on the appointment ID, and the answer is yes, because when we have an appointment, we get a different appointment date. We need to go through each attribute and put it with the primary key that it is dependent on. So here we have our ERD now, and let's just go through each entity. So we've got customer ID, primary key, surname and telephone number are dependent on that customer ID. Dog ID, primary key, the dog name and the breed are dependent on that dog ID. Treatment ID, it has a treatment name, a duration and a cost, and they're all dependent on that treatment ID. And then we have appointment ID, the appointment date, the appointment time and the groomer are dependent on that department ID. Just to recap on the aims of designing for a relational database, what we're trying to do here is ensure that we've got no duplicated data. That means data stored in more than one place. If we don't have it stored in more than one place, that means we've potentially got errors coming in, because if, say, we've got the name in two places and we need to change it, we've got to change it in two places. And obviously that could potentially lead to errors in our database. It also means we're storing data when we don't need to, and therefore we're not making efficient use of storage